video today is going to cover some really basic things about kinematics. I would recommend that you take notes. These are the four that we're going to talk about today. So let's go ahead and get started on scalars and vectors. So depending on where you are in your mathematical career, you may have already talked about scalars and vectors. And if so, then this page will be pretty easy for you, a little bit of review. But some of us have not learned about scalars and vectors yet, and so we need to make sure we cover that. So down here at the bottom, I have a bunch of stuff that some of it goes in the scalar column, some of it goes in the vector column. So, and one of them is kind of hiding down there. But let's start with this one, a single number giving a size or magnitude with units. That if it's just a plain old number, that is a scalar. Now, it might have units with it, and it should have units with it, but it's still just a number, like 10 meters or 13 seconds, something like that. However, if that number then has direction to it, then it becomes a vector. So rather than just 10 meters, we would say 10 meters to the west. Now it's a vector. And so just saying maybe 25 miles per hour, we say 25 miles per hour to the north, then it is a vector. So the difference is scalars are just a plain old number, whereas a vector has direction. That is the main distinguisher between the two. And so let's look at these two down here in red. One of these sets is scalars, one of these sets is vectors. These are all scalars. Length, like I said, 10 meters. Volume, 40 cubic feet. Speed, miles per hour. Energy, we'll talk about energy, but joules is a unit of energy. There's no direction with any of those, right? Like a volume is just a cube sitting there. There's not really direction to it. Energy also, it's like a bundle of energy, but it's not going anywhere. Now speed seems like maybe it could have direction, but that actually is called velocity when it has direction. And so that's going to be another difference that we're going to talk about in these two, in this continuing on with this lesson, is the difference between some of these things, that they seem very similar, but they're actually quite different, or they at least have a little bit of difference. So now I have some examples down here. Can you think of which would go in which column? So 9.29 meters. We talked about that a little bit ago. It is length. It is just meters. It doesn't say which direction. It's just how long something is. Now this one, that actually has a direction to it, right? Now this, you might not know this. That N stands for newtons, and newtons is a measure of force. So this is like you are pushing something in the positive y direction, meaning up, with a force of 25 newtons. Okay, 15 meters per second. Does that have a direction to it? No, it does not have a direction, so it's a scalar. Let's come over here. Now this one, ooh, I think there's two of them there. Oh, there should have been two of them there, but I didn't cut them up. Here's what we're going to do. Something's wrong with that. I'm going to delete that one off. And so the only one we have left is meters cubed, and that would be scalar. It does not have a direction to it. Let's talk about maybe, I'm going to add one here because we don't have very many in the vectors. Vectors are quite common in physics. It's maybe more of what we do than anything else. I don't know if you know the gravity on Earth is negative 9.8 meters per second squared. In this case, I'm going to say since it has a negative, that means down, and that makes it a vector. Okay, that would be acceleration. Okay, so that's the difference between scalars and vectors. Let's move on to the next concept. Distance and displacement. They're very similar. However, they are a little bit different. Not a whole lot, but they are a little bit different. So if we talk about distance and displacement, which one is a scalar and which one is a vector? Well, distance is a scalar, and displacement is a vector. And you may not have heard of this distinction before, but distance is like how far you go, total, whereas displacement is just where did you end up in the end. I'm going to talk about that a little bit more. I know that's not a very clear explanation right now, but we are going to talk about that. Displacement is, we often talk about it as change in x, and that delta, that's a delta symbol, and that means change in. Change in x is, and this equal with the three equal lines means like definition. So the change in x is the final minus the initial distance. So we're going to talk about that, okay? I'm going to maybe talk about a football field. Okay, so distance is Kansas City Chiefs are running a play. And on the first play, they run 9 yards. And then on the second, they run 5 more yards. But then they actually lose 3 yards. Well, what is their total distance? Their total distance is going to be how far did the football travel? The football traveled 9 and then 5, which is 14. And then the football traveled 3 more yards. It traveled a total of 17 yards. Now, is that their net gain? No. Their net gain is their displacement. And their net gain is 11 yards because they went 14 and then they lost 3. And so their net gain was 11 yards, but their total distance that football traveled was 17 yards. That's the difference between distance and displacement. 17 total, that's a scalar number. Like, that's just how far, if you took out your tape measure, the line judges take out their tape measure, and they measure a total of 17 this way, or a total of 14 this way, they measure a total of 3 that way. That's a total of 17 yards. Displacement, however, is a vector. And so maybe for this we should put a positive 11 yards. They moved a net positive. They had a net gain. If they had a net loss, then maybe we would put a negative sign with that. And so oftentimes in vectors, the positives and negatives will sometimes mean direction. Let's look at another example. Same concept. A ball is thrown straight upward and comes back to where it started. What is the total distance that it traveled? So here you have this ball. It goes up for, let's say, 10 meters, and then it comes back down to Earth. How far did it travel? Well, it traveled a total of 20 meters. What was the net displacement, though? The net displacement is 0 meters. In the end, it didn't actually go anywhere, right? It started here and it stopped here, same exact place. It didn't have any net displacement. So that's the difference between distance and displacement. The next topic I want to talk about is speed and velocity. And I will tell you that in physics, a lot of words that we use in physics you've heard before, and you may not have a full physics comprehension of. So a lot of us use the words speed and velocity interchangeably, but speed and velocity actually are not interchangeable in physics. We're a little bit more precise than that. And so that will happen honestly throughout the year here in physics, that we talk about something like, let's just say energy, and you have a certain idea in your head of what energy is, but in physics, that's not the same thing. So that's something that happens here. Speed and velocity, which one is a vector and which one is a scalar? Well, speed is just a scalar quantity. It just says how fast you're going, 25 meters per second. Whereas velocity is a vector. It should have some direction to it. So the examples I'm trying to tell you is that the speed, the scalar, would just be to say that object is going 25 meters per second. But the velocity would be something like 15 meters per second northward. Or we might say in physics, we might say in the positive y direction. So that's the difference between speed and velocity. Velocity has to have a direction to it. Okay, so that's one thing. Speed and velocity. Are the average velocity and the average speed of an object always the same? Well, no, they're not, because if the speed is total distance divided by total time, so let's say you're going on a bike ride, and on your bike ride you go a total distance of 10 miles, and let's say you're going really, really fast, and so it takes you half an hour. Okay, then you would be going 20 miles per hour. Now, that's if obviously you're going really, really fast. That would be a really fast bike ride. But what about you're taking your bike and you do that bike ride, and we're going to use the physics definition of velocity. And so we're going to say, okay, the average velocity is going to be the final location minus the initial location over the final time minus the initial time. Okay, so your final time was 0.5 an hour, half an hour, and your initial time, well, you started out at the 0 hour mark. Distance, though, you started out at your house, which was 0 meters away from where you were going, and you ended up 0 meters away from your house, which is 0 meters away from where you're going. So your total is 0 over 0.5, which is 0 meters per second. Okay, your velocity was 0 meters per second. Your speed, your average speed, was 20 miles per hour. Your average velocity is 0 meters per second. So there is a difference there between average velocity and average speed. Okay, instantaneous velocity compared to average velocity. So let's go back to your bike ride, and let's say the first part of your bike ride is on your street. It's pretty flat, and you are going, your velocity for that time, that section of time on your street, your average velocity for that first section of the street is, let's say, 10 miles per hour. And I'm here using miles per hour. In physics, we usually use meters per second, but just so that we have something to relate it to, we're going to say miles per hour. And let's say that that distance was, I'm just going to again make something up, for 0.1 of a mile. Then your second part of your trip is actually downhill. And so now you're really going fast. And I'm going to exaggerate here, and let's say you're going 30 miles per hour. That would be really, really fast, right? It means you're going as fast as the cars, or maybe faster. It's 25 miles per hour. And let's say for that section was also 0.1 of a mile. Okay, well then your average velocity is going to be 20 miles per hour, right? For the entire trip. Okay, is that the same as the instantaneous velocity? No, it's not. Your instantaneous velocity is how fast are you going here, or how fast are you going here, whereas your average is, over the whole trip. And so we can continue to talk about that with this concept. Is it possible to have an average speed below the speed limit, but still get a speeding ticket? Explain. All right, what do you think? Yes, of course, and you've probably done this before. Well, hopefully you haven't gotten a ticket before, but you've probably been over the speed limit, or even under the speed limit. All right, let's talk about it. So again, let's say you're in your car now. Let's say you're in your car and you start off going kind of slow, and then you get on the highway and you go on the highway, and then you get on the exit ramp and you slow down again, etc. So you have different speeds along the way. Okay, is it possible to have an average speed below the speed limit but still get a speeding ticket? So let's say we're at that part. So again, let's say your first part of your trip is out of your neighborhood. You're going 25 miles per hour. You get to the highway, you go 65 miles per hour. You get on the exit ramp and you go 15 miles per hour. But let's say on this highway, at some point during this highway, you are actually going, maybe 75. Okay, you had to pass someone. You weren't going 75 though, and that's when he caught you. You go, oh, shucks, but just back there, I was actually going slower because I was stuck behind somebody, right? But you're instantaneous. You could get that speeding ticket because that instantaneous speed is higher. But yet, even though you were stuck behind someone before that, going 55, they caught you at the 75, and yet your average for that portion might still be 65. Okay, so just consider that your speed at any given time, your instantaneous speed, is going to be different from your average speed. And that could make a difference, especially when you're getting a speeding ticket. All right, let's go to the next slide.